Hi folks, how you doing? Hope you're all safe and well. Welcome to lesson 3 of the Chemical Worlds unit. We're going to be looking at the pH scale, acids and alkalis today. But before we do, I just want to do a quick starter activity on the material that you learned last week. So, can you explain the process of evaporation of salt water? Pause the video and have a wee think about it, and then I'll come back and I'll tell you what I've thought. Okay, so the evaporation of salt water. Salt is soluble in water, so we must use evaporation to separate water and salt. So the two methods of separation are evaporation and filtration, but we're going to use evaporation because the salt is actually soluble in the water. So water is heated until it becomes steam, which is a gas. This is called evaporation. Eventually, all the water has evaporated, leaving the salt behind. So all the water turns into steam, leaving the salt residue behind. So well done if you got that. Moving on to today's lesson, we're going to be learning about pH, acids and alkalis. We will do this by exploring the properties of solutions with different pH. We're going to be doing that bit in more detail in the next video where I show you my home experiment that I did. Using different household substances like bleach, soap, lemon juice, things like that, and to try and determine their pH. And if at the end of this video you can tell me what the pH scale is and you can explain its contents, then we'll have had a successful lesson. So let's go. So have you heard of acids and alkalis before? If so, where? Can you name any substances that you know are acidic or alkaline? So pause the video and have a wee think, and if you want, you can write down some examples. Okay, so here's what I got. Acids, I had lemon juice, vinegar and tomato sauce, and for my alkalis, I had soap, bleach and baking soda. So there is no right and wrong answers here. These are my examples. If you've got something different, that's cool. Well, maybe I'm going to show you a technique to test them, to see if they're acids and alkalis. These are just examples of everyday acids and everyday alkalis. Okay, moving on to the class note. In chemistry, we use the pH scale to test the pH of a substance. We can use universal indicator, homemade if you're in lockdown, pH paper, or a pH meter. The substance that we test must be in aqueous solution, dissolved in water. That's just a fancy word of dissolved in water. So if I'm testing the pH of sugar or salt, I can't just put my pH indicator, drop it on salt. I need to make a salt solution or a sugar solution or a lemon juice solution. So it's just mixing what you want to test with water. So the pH scale runs from below 0 to above 14, but we usually say it runs from pH number 1 to 14. A substance can be classed as an acid, an alkali, or a neutral substance. So this is really important, this note here. So can you pause the video and copy this down in your jotter? Okay, moving on. So what is the pH scale then? So as you can see, we've got acids on the left, neutral in the middle, and we've got alkalines on the right hand side. So what are they asking us for? The pH numbers. We've got the pH numbers here. So 0 is very, very strong acid, all the way up to 7, which is neutral, so a neutral pH, and it continues up to 14, and we've got really, really strong alkalines here. So this idea of strong and weak acids, let's look at that. So we've got 7 here. This is neutral, and I would say maybe 4, 5, and 6. These kind of light green, yellowy colours are weak acids. Then we've got 1, 2, and 3, which are stronger acids. Then we've got 0 here, which is really strong acid. So hopefully you can see the more intense the colour gets, the more acidic. And exactly the same with the alkaline side. We've got green in the middle for neutral, and then we've got kind of blue, light blue turquoise colour. And you can see that as the numbers go up, the colours get darker and more intense. And we go 14, it's the darkest colour, that's the strongest alkalis, okay? So hopefully that gives you a good idea of what the pH scale does. So if you want to pause the video, just take a wee annotated note, copy down your pH scale, colour it in if you can, but just the most important thing, you've got acids on the left, we've got 0 to 6, alkalines on the right, 8 to 14, and we've got our neutral in the middle, okay? So green is neutral, red and orange is acid, and then blue, purple is alkaline, okay? And the stronger, more intense the colour, that means the stronger, more intense the substance. So either alkaline or acids. So let's get this together in a class conclusion, okay? So pause the video and have an attempt at this, okay? Copy this in your jotter, right? So conclusion, and then you try and fill in the blanks. Okay, welcome back. So here's what I got. Acids have colours which are red, orange or yellow. Neutral substances are green in colour. And alkalis have colours which are blue, dark green or purple. So guys, well done if you got that correct, okay? So let's have a look at our success criteria again. So we can state what the pH scale is and explain its contents. So I'm pretty confident we can do that. We know what the pH scale is, we know why it's used to measure how acidic or how alkaline a substance is. If we put universal indicator into a substance and it turns green, then it's neutral. If it turns a dark green, blue, purple colour, it's an alkaline. If it turns a orangey, red colour, it's an acid. And the intensity of the colour tells you how strong or weak that substance is. We know the numbers go from 0 to 14. And I think that's it. So if you can do that, well done. If not, then just have a look over your class notes again and maybe even watch the video again to get it clear in your head. Again, any questions, please just let me know. Thank you very much and I'll see you next time. Thank you. Bye.